All right, hi math class. We're going to look at sinusoidal functions today. I'm going to show you lots of stuff on my calculator. All right, sinusoidal functions can be written like this. So it's sine with four numbers, A, B, C, and D. We're going to investigate what each of these things does to the graph. In order to do that, I first want to just look at what sine x looks like. So I want to make sure I'm in radians. It's going to be simpler for this exercise here. I'm going to change my window settings. I kind of know what I'm doing. Trust me here. I'm going to go from negative 2 pi to 2 pi. I'm going to make the scale, say, pi by 2. For y min and y max, I want to go from negative 2 to 2. Okay, now let's graph. Oops, spoiler alert. I'm going to graph sine x here. Let's have a look. Okay, so I think you know what sine x looks like. So this is just the graph. This is the basic sine graph. My window's negative 2 pi to 2 pi. It looks like it repeats itself after 2 pi. From negative 2 pi to 0 is a full cycle, and from 0 to 2 pi is a full cycle. We'll discuss that. The maximum value, maybe let's calculate that. Second calc. You might know from a previous math course, but I want to prove it here. Left bound, right bound, here we go. So the maximum value is y equals 1. Okay, I'm going to write that down here. Max equals 1. What do you suppose the minimum is? I think you can tell by looking, but we'll do the same thing. So our minimum, I'll choose the one over here. Okay, minimum looks like negative 1. Okay, the space on the graph that it travels before it repeats itself is called the period. That's what I discussed a little bit. This thing repeats itself in 2 pi. So this is negative 2 pi to 0, then repeats itself 0 to 2 pi. That's called a period. Okay, that all looks good. So that's what sine x looks like. That's the basic graph. Now what I want to do is start messing with it a little bit. So what do I have here? I said, let's look at y equals 2 times sine x. I'm actually going to leave sine x there. Let's do 2 times sine x and see what's different. All right, so it's going much higher and much lower, but it looks like the period is the same. Looks like it's changing the maximum and the minimum. Okay, let's actually investigate. Let's calculate a maximum. Oh, I think I'll need to actually delete. Nope. Okay, so now notice I'm tracing 2 sine x, which is nice. I'm going to find the maximum. I think it's going to be 2. Check it out. The maximum now is 2. So when there was a 2 in front of sine x, the maximum is now 2. The minimum, you can take my word for it. I'm not going to go through it to save some time. The minimum is negative 2. The period didn't change. It's still 2 pi. Okay, so what we just determined here is the number out in front. This is like the maximum or the minimum. We're going to have a new word for it soon, but that's what we just determined. That's what A is. A is the number that multiplies by sine. That affects clearly the maximum and the minimum. Okay, so we know that A now affects max and min. Okay, what else have I written down here? Now I want to try sine of 2x. See how that changes the graph. So I'm going to get rid of the second one. I'm keeping sine x so we see what the regular graph looks like. Now I'm going to graph sine of 2x. So this one's sine x, it's regraphing it. Let's see what sine 2x looks like. Whoa. Check it out. So I don't think the max or the min has changed. I want to actually delete sine x just briefly so we can better look at this guy. This one's just moving more. It's oscillating more. There are more periods in that window. Check it out. If I want to isolate a period, I would say starting at 0 to here. And I put little marks every pi by 2. That's the second mark. or you can say there's 2 periods in this window from 0 to 2 pi. That changed the period. The period here is just pi. Okay, so that number, it didn't change the max or the min. There's still 1 and -1, but it did change the period. The period here is pi. So if we go back to our master formula here, what I did is I changed b. I made b equals 2. This one definitely affects the period. That's what I noticed. I hope you agree with me. Okay. I'm going to bring back sine x, because now I want to see what happens if you subtract something. Okay, so it's going to regraph sine x. The next one's going to be what sine of x minus 1 looks like. Oh. I think you'll agree that just moved it horizontally, just shifted it. Cool. Okay, so max, min, period is totally the same. Max is 1, min's -1, period was 2 pi. So in our master formula here, c, this is the least important number, but what we just saw is it's a horizontal shift. Last one, let's figure out what d does. So that's when you add something outside of the bracket. Okay, so I'm keeping sine x. This time I'm going to do sine x. Make sure you close the bracket, plus 1. Let's see what we get. So this one's sine x. Sine of x plus 1. Moved it up. So that's a vertical shift. I want to find its max and min. Maybe just the max. Okay, so the maximum here is 2. The minimum, I can actually tell by looking. It just hits the x-axis, 0. The period didn't change. Okay, so this number is a vertical shift, an up-down. Okay, so this is what generally these numbers do. So the first number makes it go higher and lower. The second number makes it oscillate more. This number moves it left or right, and d moves it up or down.